We can use the Pythagorean theorem to find the distance between 2 points on a coordinate plane. So as a reminder, the Pythagorean theorem is a squared plus b squared equals c squared, where a and b are the legs of a right triangle, so they form together to make that right angle, and then c is the other side, the longest side, also called the hypotenuse. So if we have these 2 points, we could look at the rise, which we're going to go up 1, 2, 3, 4. Okay, let's maybe say that's what A is. That'll be one of the legs. And then we'll run across 1, 2, 3, 4, 5, 6. So 6 would be the other leg. And that is equal to the hypotenuse, which we'll call C. All right, so 4 squared is 16, plus 6 squared is 36, and that is equal to c squared. So 16 plus 36 is 52, which equals c squared. And then if we pull up a calculator, we then, to unsquare that, the inverse is to take the square root. So 52 and the square root of that would be 7 21/100. All right, here's our next example. Let's say we start at the top point here. We'd have a rise, which would technically in this case be a fall. We'd have to go down 1, 2, 3, 4, 5. So that leg is 5. And even though we're falling down, distance is still always measured positive. You can go 5 this way, 5 this way, 5 this way, whatever. So distance is always positive. Okay, so the length of that rise would be 5. Then you'd have to run 1, 2, 3. So that would be 3. They form a right angle, so those are the legs. And then the other side is called the hypotenuse, which is C, and we're going to solve for the length of that line. All right, so 5 squared is 25. 3 squared is 9, and that is equal to c squared. 25 plus 9 is 34. And then to unsquare that, we have to take the square root. Whoops, I put in the wrong number. 34 square root. All right, so that would be 5 83/100. What if we don't have a picture? This is where the distance formula comes in handy, but you still could definitely just use the Pythagorean theorem. This is what the distance formula looks like, where x2 and x1, those are your x values from both of your coordinates. So x2 would be 11. X1 would be 3, so we need to subtract those to find the difference between them. The difference between them would be how long that leg is. All right, so 11 minus 3 would be 8, so we'd have 8 squared. And then if we did 9 minus 2 squared, that would be 7 squared. Ooh, so this looks like a squared plus b squared. And then when you say it's like equal to c squared, you end up taking the square root. So we're just going to say you're going to take the square root of all of this to get the distance. So we have 64 here plus 49 here. All right, so when we take the square root of 113, probably should have drawn that square root symbol, we get 10 63/100. Okay, so again, I'm just going to show you how this kind of lines up. If we subtract those x's, and we get that 8 squared, and then subtract the y's, and we get that squared, if we wrote it as equals c squared, we'd still end up taking the square root. So that's why it's the same thing. So you can either use the distance formula, or you can still use the Pythagorean theorem and still just solve for c. Let's try one more. All right, let's try this one that has some integers, which are some negative numbers. right? So if we do -1 minus -2, I'm going to write that out like this. You can change subtraction to addition and add the opposite. So it's the same as -1 plus +2, which is 1. So we're going to have 1 squared. So 1 is the distance measurements for one of the legs. And then -5 minus 7. You could keep it like this, or you could say it's the same as -5 plus -7. So you lost $5, and then you lost $7. So altogether, you lost $12. Okay, so we have to add those together, and then we'll end up taking the square root. 1 squared, 1 times 1 is 1. No silly business, don't you dare say that's 2. Plus, we are multiplying -12 by -12. A negative times a negative is a positive. So 144. If we add those together, we get 145, and we need to take the square root of that number. 145 square root. You know, I was hoping I'd get an answer that involves rounding, but none of my examples have. All right, so that answer is 12 400ths. Let's just say my calculator said 12.048. It doesn't, but let's just say it did. If the third digit is 5 or higher, you need to add on a penny, and you would then round this one up to 12 500ths. And one last thing, let's see, I'm just going to write it here in the middle. If you get an answer, and let's say it's 3.80, your answer only needs to be 3 8/10. You don't need that extra 0 at the end. So that might come up in your work today.